Today we're going to start with new content, as you'll have seen from Show My Homework, and we'll have a little look at inequalities. So to begin with, we'll just run through the notation and some definitions, and then run through some examples. And we'll sort of build on that this week. It is quite similar to equations, but there are differences. So initially, again, it might seem quite straightforward, but I just want to run through everything sort of thoroughly so that you can sort of see where each bit comes from. So to begin with, we'll look at some notation. Here, these are called strict inequalities. You don't need to know that definition, but what that means here, for example, where we've got x arrow A, the small point of the arrow is by the x. So this means x is less than A. Going to try and make that a bit more in focus for you. Okay. Here we can see that the sort of larger outside part of the arrow is by x, and so that's quite a helpful way to remember. As the bigger side is by x, x is greater or bigger than b. Now, these signs here look quite similar, but you can see that there's the extra line here. So what that means here is that x is less than or equal to c. Okay, so x is less than or equal to c. And then this one here means x is greater than or equal to d. So we're going to use that a little bit later when we write inequalities on number lines. So I'm just going to give a few notes on sort of writing inequalities on number lines and what sort of different things mean. So the first thing is if you have got a sort of hollow circle drawn there, this refers to strict inequalities. So either your less than or greater than sign. If you've got a coloured in circle on your number line, that's your equality. So your less than or equal to, or your greater than or equal to sign. The last note here, if you've got an arrow, and I'll give you an example of this in a minute. So say, for example, if you've got an arrow like that on your number line, or if you've got an arrow like this, this means that there's an infinite number of values for x or whatever the variable is. So it may be on a number line that you have a distinct number of values, so your two sort of inequality bubbles go between two values, or it might be that you're just saying x is less than 5, and it could be any value less than 5 down to negative infinity. Okay, so for example, if I just show you here what that means, here if we say x is less than 4, well, I would need to draw a non-shaded circle and just an arrow pointing in the negative direction, and that means x is less than 4, and that carries on forever. On the same number line, I'm going to do x is greater than or equal to 2. So that would be my shaded in circle here, and the arrow would be going in the positive direction, like so. Now it might be, as I said, that you have a distinct number of values. So now on this number line here, I'll write the inequality negative 1 is less than x is less than 4. So we've got negative 1 and 4, and x would go in between any of those values there. So you don't need an arrow, you would just connect like so. Okay, so that's the difference on those ones. So if we quickly run through a few examples, first of all, you've got completed number lines and you need to write down the inequality, and then a little bit later I'll give you the inequality and you need to write that on a number line. So here, write down the inequality shown below. Well, here you've got an open circle and 3 going in the negative direction, so x must be less than 3. Here you've got a shading circle, so it's going to be a greater than or equal to or less than or equal to. Here it's going in the positive direction, so you can see that x is greater than or equal to negative 1. Part I, we've got x is within two values, so x is greater than -3 and less than or equal to 2, and your signs here are really important. So we've got -3, x is less than -3. X is greater than -3 and x is bigger than or equal to 2. And I would sort of represent that as so you've got it as one sort of writing there. Okay, and part IV, here x could be either of these. It couldn't satisfy both. So here you can see x could be less than or equal to -2, or x is bigger than 3. Now x can't satisfy both, which is why we put the or in the middle, not the and. So what I would like you to do now is pause the video there and you have a go at these number lines here. You can just write out what the inequality would be, which is represented. This is also on the slides, and then I'll run through the solutions in a minute. So pause and have a go. Okay, so hopefully you've had a go there. Here you can see on part I the answer is x is less than or equal to 5. On II, x is greater than -2. On part III, x is greater than or equal to -1 and x is less than 4. And on IV, we can see that x is less than -3 or x is greater than or equal to 0. And make sure that you've got your signs correct there as well. Okay, last couple of examples we'll run through quickly. Here you're given the inequality and you need to represent this on the number line. So first we've got that x is bigger than -3. So hollow circle on -3. X is greater than that, so we'll be going in the positive direction, and I can just draw that as an arrow, and that'll include all values up to infinity. Part II, x is less than -2, so an open circle there, or x is bigger than or equal to 1, so shading circle there. Now x is less than -2, so that will go in the negative direction, and x is greater than or equal to 1, so that will go in the positive direction, and your number line would look like so. Same as before now, if you can pause the video there, have a go at the your turn questions. They're also on the slide, and then we'll run through them in a minute. Okay, so part I here, we've got x is less than 4, so open circle on 4, that's going to be going in the negative direction as an arrow. And part II, x is less than or equal to 0, so shading the circle on 0, going in the negative direction. Or x is bigger than 3, so that will be a hollow circle there, going in the positive direction. And so that there should be what your number line looks like. Okay, there's now a task on the slides for you to have a go at, which I've also uploaded as a PDF called exercise 1. So I just suggest you pause the video there, go and have a go at that sheet and mark the solutions, and then come back and we'll run through some notes for the next part of the lesson. So go and have a go at that, pause this, and then come back. Okay, so final bit that we're going to have a little look at today is how we can go on to manipulating inequalities. So the first thing that we'll have a little look at is, say for example, if I had the x is greater than 3, Just like with equations, you can subtract or add the same value to both sides of the inequality. So here I'm going to say, right, I'm going to subtract 1 from both sides, and x minus 1 is bigger than 2 holds as an inequality, and we've just subtracted 1 each time. So you can add or subtract a value from either side of the inequality, like so. Number 2 says 2x is greater than 6. Now again, we can divide by a positive whole number on both sides of the inequality. So here, if I divide both sides by 2, then x is greater than 3, and you can see how the process is quite similar here to solving an equation. If we have a look at the third one, I'm going to say x is less than 1. Now we can multiply both sides of my inequality by any positive whole number. So if I'm, say, going to times both sides by 4, then 4x is less than 4 also holds. Now this fourth one is a little bit different. Okay, so this is the main difference with inequalities and something which often catches people out and we need to remember. So if I write negative x is less than 4, we're going to have a look at how I could then solve that to find x. Now before I do that, I'm just going to write over here, using sort of a numerical example to help. I'm going to say, right, 2 is less than 4. Now here, if I times both sides by negative 1, I will get negative 2 and negative 4. And now thinking about how I should write the sign, well, negative 2 is greater than negative 4. So my sign will change. And the same is true whenever you want to multiply or divide an inequality by a negative number. So here, if I multiply both sides by minus 1, I will get x and minus 4, and the inequality sign will flip. So x is greater than negative 4. And there is a note about this on the slides. So we cannot multiply both sides by a negative. If we are to do that, we need to flip the sign. You can't just do that and keep the sign as it is. Okay, so use that to help you. There's a few questions on a final slide just to check our understanding with that, and then we'll come on to a lot more of that tomorrow.